Hi guys, this is Vineet and I welcome you to this video. Today's video topic is index maintenance methods, which are reorganize and rebuild in SQL Server. Before we proceed ahead, I would request you guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button, it will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my upcoming and future videos. The reason I'm asking you to subscribe is because I'm creating index videos on indexes these days, and I don't want you to miss on any of the videos that I'm creating on indexing topic. So that's the reason I'm asking you to subscribe. So please go ahead and subscribe right away. I'm waiting. There's a subscribe button below. Click on that button and follow the process. So guys, I hope you must have subscribed by now so we can move ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept, and if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our video, so please share in your comments and suggestions. Also share your feedback as well. We eagerly wait for your comments and suggestions and would love to read the same. So do post in your comments and suggestions, guys. We have created some playlists for you to watch. Some of the popular SQL Server playlists are SQL Server Database Design, SQL Server Tables, Business Continuity, Indexes, Performance Tuning, Integration Services, and Transact SQL. If we talk about this video pertains to the SQL Server indexing category, and this playlist is growing day by day. We have more than 25 videos at present in this domain. Guys, the reason we create playlists for you because we feel that the playlists are best way to learn about any topic instead of watching videos randomly. So for example, if you want to learn about SQL Server indexing topic, for example, then what I would recommend is please go to the SQL Server indexing playlist and watch out all the videos from starting till the end to get better grasp on the indexing area. If we talk about the total number of videos posted on our channel, we have more than 250 videos posted on our channel and the list is growing day by day at a constant pace. My channel page link is given at the bottom of this slide. Also guys, the link to all these playlists and my channel page link is also given in the video description area of this video. So please check out the video description area to find out the links related to these playlists and my channel page link as well. Now let's come back to today's topic, which is index maintenance method. So today we will discuss about the index maintenance methods. Some of them are reorganize and rebuild of indexes. These are the method used for index maintenance in SQL Server. Alright, so today's topic is we will discuss about the index maintenance method, and these methods are reorganize and rebuild. We can reduce the index fragmentation. So if you haven't watched my earlier videos on index fragmentation and page density, please go ahead and watch them out if you want to continue with this video. It would be helpful if you watch those videos related to index fragmentation and density before you can proceed with this one. Now let's begin. We can reduce the index fragmentation and increase the page density of the index by using one of the following methods. So there are two methods to reduce the index fragmentation and to increase the page density of an index. First is we can reorganize an index. Second is we can rebuild an index. Now for any partitioned indexes, if we talk about, we can use either of the above methods on all the partitions or maybe a single partition of an index. So partitioned indexes are basically where indexes are partitioned into various partitions, and if they are partitioned into various partitions, we can build rebuild or reorganize each of the partition individually as well. So that's the benefit of partition indexes. Now let's talk about reorganizing an index. Now if we talk about reorganizing an index is less resource intensive rather than rebuilding an index. So this operation, reorganizing operation, is less resource intensive compared to rebuilding an index altogether. And as it is consuming less resources, or as it is less resource intensive, for that reason it should be your preferred index maintenance method. So we should prefer reorganize over the rebuilding of index. So wherever possible, we should only reorganize the index instead of rebuilding the complete index, unless there is a specific reason to use index rebuild. Now, reorganize is always an online operation. So if we talk about reorganize as an operation, it's an online operation. What do we mean by online operation? This means that long-term object level locks are not held on the object. In our example, a table on which the index is built. It means that long-term object level locks are not held on the table, and queries or updates to the underlying table can continue during the alter index reorganize operation. Whenever we use reorganize operation, it does not take long-term object level locks. So long-term object level locks are not held, and queries or updates to the underlying table can continue during the alter index reorganize operation. Now we talk about row store indexes. I'm talking in terms of reorganizing an index. And if we talk about the row store indexes, the database engine defragments only a leaf level of clustered and non-clustered indexes. So if we are performing a reorganize operation on row store indexes, this operation only defragments only leaf level nodes of clustered and non-clustered indexes on tables and views by physically ordering the leaf level pages to match the logical order of the leaf nodes. So what happens during the reorganize process, and how the indexes are defragmented? Basically, leaf level nodes or leaf level pages are physically ordered to match the logical order of the leaf nodes from left to right. Now, reorganizing also compacts the index pages as well to increase the page density basically. So, reorganizing also compacts index pages to make page density equal to the fill factor of the index. So, during the reorganize operation, compactation also happens for any of the index pages so that the page density becomes equal to the fill factor. So, guys, we have talked about fill factor in our earlier videos as well. So please watch those videos out before proceeding with this video. To view the fill factor settings, you can use the sys indexes catalog view. In our earlier video, we had shown you the query to check the average fragmentation and the fill factor or the page density of a particular index. So you can check my previous video out, the one I created just before this video. That's the useful one. Now, if we talk about any column store indexes, there's a concept of delta store which we will discuss later. And delta store is a separate area inside the column store indexes. So the delta store may end up with multiple small row groups. So if we talk about column store indexes, there's an area called delta store, and this area may end up with multiple small row groups after inserting, updating, and deleting data over time. So over time we insert data into tables, update data in the table, and delete data from the table. So this results in small row groups in the delta store over the period of time. So reorganizing a column store index basically forces delta store row groups into compressed row groups. So whatever row groups are there in the delta store, it compresses those row groups, it turns them into compressed row groups in the column store and move them to column store basically. And basically also combines smaller compressed row groups into larger row groups. So there are two operations happens in the reorganize process in the delta store particularly. So if there are any row groups in the delta store, these got compressed into compressed row groups in the column store. And it also combines smaller compressed row groups into larger row groups, and that is the second operation that gets done. Reorganize operation also physically removes rows. So under this reorganize operation, this operation also physically removes rows that have been marked as deleted in the row groups. Alright, so it physically removes rows that have been marked as deleted in the column store row groups. Now, reorganizing a column store index may require additional CPU resources to compress the data. So during the reorganizing of column store index, the compression also happens. So this compression requires additional CPU resources to compress the data, which may slow down the overall system performance as well, because it is the compression process consumes the CPU, and this reduces the overall system performance while the compression operation is running. However, once the data is compressed, query performance improves. We talk about SQL Server 2019. Started with the SQL Server 2019. The tuple mover is helped by a background merge task that automatically compresses smaller open delta row groups that have existed for some time as determined by an internal threshold. So if we have SQL Server 2019 and beyond, there's a tuple mover process which is also helped by a background merge task, and the role of these tasks is to automatically compress smaller open delta row groups that have existed for some time, and this time is determined by an internal threshold. Once this time is passed, the merge task automatically compress the row groups from where a large number of rows has been deleted. The merge task runs in the background to compress any row groups from where a large number of rows has been deleted. And this basically improves the column store index quality over time. And for most cases, it dismisses the need for issuing alter index reorganize command. So this merge task automatically take care of compression of any row groups where rows have been deleted, and this facility is available SQL Server 2019 and beyond. And basically this facility eliminates the need for issuing any alter index reorganize commands, because index is automatically maintained. Basically we are talking about column store indexes. These are automatically maintained via the merge task starting SQL Server 2019 and beyond. Now if you cancel a reorganize operation, so here we are talking about a reorganize operation, and if you cancel this operation in between, or if it is otherwise interrupted in between, the progress it made to that point when it was cancelled or when it was interrupted, so the progress it made to that point is persisted in the database. So the progress remains there even though you cancel the operation or even though you interrupt the operation, the progress persists in the database. And to reorganize large indexes, basically the operation can be started and stopped multiple times until it completes. So it is very useful operation. For whatever time it runs, it persists those results in the database, and this operation can be started and stopped multiple times. And this operation can be started and stopped multiple times. And this operation is basically very useful for reorganizing large indexes, as we can stop and start this operation multiple times, and progress made by this operation is persisted in the database till the time it is cancelled or otherwise interrupted. Alright, let's talk about rebuilding an index compared to the reorganization of index. So if we talk about rebuilding an index drops and recreates an index altogether. So first it drops an index, then it recreates a particular index. Now depending upon the type of index we are talking about and the database engine version as well, a rebuild operation can be done in an offline or online mode. So this operation can be performed in offline as well as online mode. An offline index rebuild usually takes less time than the online rebuild. So the offline index rebuild operation is much faster than an online rebuild operation. But if we talk about the online rebuild operation, so let's not talk about the online rebuild operation. If we talk about the offline rebuild operation, it holds the object level locks for the duration of the index rebuild process. So the offline index rebuild operation holds the object level locks for the duration of the rebuild operation. And it basically, if we are rebuilding an index in an offline mode, it blocks the queries from accessing the underlying table or view. So we cannot access any underlying table or view if we are rebuilding an index in an offline mode. Whereas if we compare an online index rebuild mode, so an online index rebuild operation does not require object level locks until the end of the operation. So this online index rebuild operation do not need the logs or object level logs for the whole time the operation is running. And when a lock must be held for a short duration. So in this online index rebuild operation, an object level lock is held only for a shorter period of time. So when a lock must be held for a short duration to complete the rebuild. So let me change it to where. So under the online rebuild index operation, lock must be held for a short duration to complete the rebuild process. And depending upon the version of the database engine you are using, an online index rebuild can be started as a resumable operation. So depending upon the SQL Server version or the database engine version we are using, this online index rebuild operation can be started as a resumable operation. So what do we mean by a resumable index rebuild? A resumable index rebuild can be paused at any time, keeping the progress made till that point. So whenever we pause an online index rebuild operation which is resumable, um, the progress made till that point gets persisted in the database, and a resumable rebuild operation can be resumed after having been paused or interrupted. So we can resume a resumable index rebuild operation. It can be resumed after having been paused or interrupted or even aborted if completing the rebuild becomes unnecessary. So sometimes we abort the operation as well if the rebuild becomes necessary. So that's the benefit of the resumable index operation. Now when an index is being built online, so whenever we rebuild an index in an online mode, every modification to a data in the index columns must be updated in the additional copy of the index. So that index, additional copy of an index is known as the mapping index, and we have discussed about this in our previous video. So watch out the previous video before you start watching this video. Whenever we rebuild an index online, the underlying tables are available to the user. So a user can issue query against those tables, queries like the select queries and the update queries. So every modification made to the data in the underlying tables and in the index columns, associated index columns, must update an additional copy of the index. So if we are rebuilding an index in an online mode, an additional copy of the index is created, which is known as mapping index. And that index basically keep track of the every modification made to the index during the online rebuild operation. And this may result in a minor performance degradation as well of the data modification statements during the online rebuild. So as an additional index is created, this results in the minor performance degradation of data modification statements like update and delete during an online index rebuild operation. Once an online index rebuild operation completes, performance comes back to normal. Now, if an online resumable index operation is paused, so if we are running a resumable index operation in an online mode, and if that operation is paused, this performance impact persists until the resumable operation either completes or is aborted. So if we pause any resumable index operation in the paused mode, this affects the performance, and this performance impact persists until the resumable index rebuild operation either completes or it is aborted. All right. And basically we would recommend, if you do not intend to complete a resumable index operation, abort that operation instead of pausing it. That's the recommendation. Now, depending upon the available resources and workload patterns, specifying a higher than the default max stop value in the alter index rebuild statement may shorten the duration of the rebuild at the expense of the higher CPU utilization. So while doing an alter index rebuild operation, we can increase the max stop setting, which is max degree of parallelism, where the large number of CPU cores can be used faster perform any operation. So we can increase the value of max stop during the alter index rebuild statement, and this basically shorten the duration of the index rebuild, and but it requires the high CPU utilization. Now, if we talk about the row store indexes in terms of the reorganize process, not reorganize, this is rebuild process. So if we talk about row store indexes in terms of rebuilding the indexes, rebuilding removes the fragmentation from the row store indexes in all the levels of the index, not just at the leaf level, but at various level of index, the fragmentation removal gets happened. And this process also compacts the pages based on the specified or current fill factor. So compactation also happens depending on what the value of fill factor is. And also the defragmentation happens for all the pages at all the levels of the indexes, not just at the leaf level. And when all is specified during the rebuild operation, all indexes on the table are dropped and rebuilt in a single operation. Now, if we talk about indexes with 128 or more extent consumed by them, so if any index is consuming 128 extent or more, and an extent is basically a unit of storage in SQL Server, and it consists of 8 pages. Index with 128 or more extents are rebuilt. The database engine defers the page deallocations and acquiring the associated logs until after the rebuild completes. So this is the point you can remember. So for any larger indexes, the database engine defers the page deallocations at that time, and also it also defers the acquiring of associated logs until after the rebuild operation completes. This is true for any larger indexes which are greater than 128 extents or more. Now, if we talk about the column store indexes, rebuilding basically removes the fragmentation, moves any delta store rows into the column store area, and basically physically deletes the rows that have been marked for deletion. So during the rebuild process, rebuilding removes any fragmentation from these indexes, and basically it moves any delta store rows into the column store rows, and it also physically delete the rows that are marked for the deletion. So this is what happens during the rebuilding process of the column store indexes. Now if we talk about SQL Server 2016, starting with this version, SQL Server 2016, rebuilding the column store index is usually not needed. So if we are running SQL Server 2016 and beyond, rebuilding of this SQL Server column store indexes is not needed, since Reorganize performs the essentials of a rebuild as an online operation. So we should use reorganization or reorganize operation on the column store indexes. So that should be sufficient for column store indexes, and we should not be rebuilding any column store indexes. And basically this is not required. Rebuilding is not required for any column store indexes starting with SQL Server 2016 and beyond. Now using index rebuild to recover from data corruptions. So basically sometimes we perform the index rebuild process to recover from any data corruption in the indexes. We also perform the rebuild operation. In the earlier version of SQL Server, we could sometimes rebuild a row store non-cluster index to correct inconsistencies in that index due to data corruption in that index. So if we talk about the earlier version of the SQL Server, if we found any inconsistencies in the index due to data corruption happened in the index, we sometimes rebuild the row store non-cluster index. Now, starting with SQL Server version 2008, you may still be able to repair such inconsistencies in the non-cluster index by rebuilding a non-cluster index offline. So if we rebuild the non-cluster index in an offline mode, it will clear out any inconsistencies in those non-cluster indexes. However, we cannot repair non-cluster indexes inconsistencies by rebuilding the index online. So if we are rebuilding a non-cluster index in an online mode, we cannot clear out any inconsistencies in that index or cannot repair those inconsistencies in the index if we are rebuilding that index online. But yeah, if we are rebuilding that non-cluster index in an offline mode, it will repair any of the inconsistencies in the index. And if we talk about the online operation where the inconsistencies are not repaired, because the online rebuild mechanism uses the existing non-cluster index as the basis for the rebuild. So if we are rebuilding an non-cluster index in the online mode, it uses an existing non-cluster index as the basis for building the new index. And basically the new index will carry over any inconsistency that are present in the previous indexes if we rebuild the non-cluster index with inconsistency. So rebuilding the index offline sometimes force the scan of the cluster index as well. So if we are doing a rebuild index operation in the offline mode instead of online mode, it sometimes force the scan of the cluster index. Alright, let me repeat. Rebuilding an index offline sometimes force a scan of the cluster index. It sometimes force the scan of the heap as well, which is a table without the cluster index. And so replace the inconsistent data in the non-cluster index with the data from the cluster index or heap. So whenever we are rebuilding a non-cluster index offline, it sometimes force the scan of the cluster index, and sometimes it forces the scan of the heap if the cluster index is not present, basically to replace any inconsistent data in the non-cluster index with the data from the cluster index or heap. To ensure that the cluster index or heap is used as the source of data, so basically to ensure that cluster index will be used or heap will be used as a source of data, drop and recreate the non-cluster index instead of rebuilding it. So we can also use the drop and recreate operation. Rebuilding is also the same if it is done in the offline mode. It basically drops and recreates the index. Now, as with the earlier version, if we talk about, we recommend recovering from inconsistencies by restoring the affected data from the backup. So the way to recover from any inconsistencies is we can restore data from the backup as well. However, you may be able to repair the non-cluster index inconsistencies by rebuilding it offline or recreating it altogether. So alright, let me take you through some of the demos now. So let me take you to SQL Server. So first we will talk about maintaining indexes using the SQL Server Management Studio. Then we will delve into how you can use the transact SQL to maintain the indexes. So in our earlier video, we had shown you a query where you can determine how to check the fragmentation of the index as well as the density of the index. We will run that query once again. I hope you have watched my previous videos and have noted down the query and have written the query as well as executed that query. Now SQL Server is opened. I had saved the queries from my previous videos, so I can execute them directly. So we will execute that query against the my AdventureWorks database. In your case, it will be AdventureWorks 2022. I had renamed my database to my AdventureWorks, so that's the reason it has a different name. Now let's use the query page density and fragmentation for row store indexes. So this database does not have any column store indexes, so that's the reason I'm not using the query associated with the column store indexes. So this is the query we have. You can take a snapshot. We can run this query in detailed mode as well, although we ran it in the sample mode. Let's run this query in the detailed mode. So we got the information, like we got information about 310 indexes present in this database, and it is giving us what type of index it is, and it is also talking about the average fragmentation and the page density over here. Now we can order, instead of ordering it by page count, we can order it by average fragmentation in percent, or maybe we can order it by 1 2 3 4 fifth column. So let's order it by 5 descending. So if we talk about this index person.person table, it is 100% fragmented right now, right? We can rebuild this index. And if we talk about the page density of this index, average page space used in percent, or the page density is 76%. Alright, so average density is 76% and the average fragmentation level is 100% at present for person.person table. Now let me show you how you can perform the rebuild of this particular index. So the index in question here is pk underscore person business entity ID is the index. Now we will talk about how you can reorganize or rebuild a particular index in table. If your fragmentation is 100%, it is generally suggested to rebuild the index instead of reorganizing it. We should go to Object Explorer, which we are already there. We should expand the databases section, which is already expanded, that contains the table on which you want to reorganize an index. So let's expand the database, and it contains the table, which is person.person we are talking about. So guys, we basically rebuild the index which are like 100% fragmented, and we basically try to reorganize the index which are like 50% fragmented or so. We can also take this human resource index, human resources dot employee table has an index AK employee, national ID number, which is a non-cluster index and is 50% fragmented. We will try to reorganize this index. Now we should expand the table. Let's take this table, human resources dot employee. So human resources dot employee is the table. Let's expand on that. There is indexes section. You should expand the indexes folder. So once it is expanded, you need to right click on the index you want to reorganize, and you need to select reorganize. So in our case, let's take this index, national ID number, which is the second index. It's a unique non-cluster index. So right click on it, and there's an option you will get to reorganize the index. And basically it will open up a reorganize indexes dialog box. We should verify that the correct index is in the indexes list. So the index name here is correct. We are reorganizing the AK underscore employee underscore national ID number index. So we should verify that the correct index is in the indexes to be reorganized grid. So this is indexes to be reorganized grid, and the index name is correct, and we should select OK after that in order to reorganize that index. So let's do that. Alright, so this index is reorganized. We can check this index by telling i.index name. We can specifically check for this index now. i.index name. Is it index ID? Index name. i.name is the index name. We can take that name as this one. To see its average fragmentation, earlier it was 50. Let's see what's the fragmentation right now. So right now, if we see, there is no average fragmentation on this index. So we are fine here. Although it is listing out two instances, but yeah, both of them are right now not fragmented. Let's remove this line and run the statement altogether. Now it's not coming in the list because I've sorted by average fragmentation. That index is not coming, which was there on the human resource employee table. It is not fragmented anymore. So we have just shown you how you can reorganize a particular index, right? So there's also one more option whenever you reorganize the index. At the bottom of this window, you will see this option, compact large object column data. We basically select this option to specify that all pages that contain large objects or LOBs, that data should also get compacted. So if you check this option, it will also compact any large object column data as well. Now we will show you how you can reorganize all the indexes in the table, how you can do that. So all the procedure basically is the same up till you get to the indexes folder. So for example, if we want to rebuild all the indexes present over here, what you need to do, if you want to rebuild all the indexes in a table, you can go till the indexes folder, right click on that folder, and you will get the reorganize all option. If you click on that option, you will get the reorganize indexes dialog box, and again you need to verify whether all the index names are correct. If you want to remove any of the indexes, you can remove it from here using the delete key. You can remove those rows. So if we take a look at indexes here, only one index is fragmented, even though we are rebuilding them all, which is not required at all. But for just demonstration purpose, we are rebuilding all the indexes. But otherwise, if we talk, rebuilding of all the indexes is not required here because only one index is fragmented. So basically we will just verify the name of the indexes present are correct. We should verify that the correct indexes are in the indexes to be reorganized grid, and we can remove any indexes. So for example, if we don't want to rebuild certain indexes, we can remove them as well. Let's remove some of them. Let's rebuild these three only. even though still these two indexes are not required to be rebuilt. Again, this dialog box is available and we have discussed it previously. It can be used to specify that all pages that contain large objects must also be compacted. Now after this you need to click on OK to reorganize all the indexes in the table. Let's move over to demo 2, in which we will show you how you can maintain indexes by using the transact SQL statement. So let's go back to the SQL Server and let's run this statement again to check out the fragmented indexes. We have some of them listed here, starting with fragmentation of 100%. We will take you through an example where we will rebuild the index. Let's rebuild this one because this is 100% fragmented. So let's copy this index name. This is on person.person table. Let's execute a new query. And if we talk about this index right now, it is 100% fragmented, right? So let's reorganize this index using the transact SQL statement. So use the alter index statement and specify the name of the index, and it is present on the, we need to check the table, so it is present on the person.person table. So you need to specify the person.person table here. So after you specify the table name, you specify the keyword reorganize if you want to reorganize this particular index, and put a semicolon afterwards. Now let's reorganize this index. So this operation is completed successfully. Our index is reorganized and we can check this index as well. So copy this out, and so right now it is showing us the multiple copies of the index, and one of these indexes is still showing me 100% fragmented. The one with the largest page count is not fragmented at present. So even after reorganize operation, this index is still fragmented. So we should consider rebuilding that index. Now let's try to use another index. Let's see what's the status of an index ix underscore employee underscore organizational level. So even after reorganization, we saw that this index is 100% fragmented. So we should consider rebuilding it. Now I'm taking a look at the situation of another index. This is the index name. Let's try to execute this statement. So it is not showing me index with that name. So this index should be present on the human resource employee table. So let me check that. So let's take a look at the indexes of this table. So this is the index. Spelling name are not correct, I'm not sure. So it's not organizational, but it's organization level, and same is true for note. Let's try to execute this statement now. Now if we take a look at this index, right now it is not fragmented at all. It's 0% fragmented. Let's try to rebuild it. Again, the statement is same. You can copy this index name, and it is on human resource.employee table. Again, there is no need to rebuild this or reorganize this index as it is not fragmented at all. But yeah, just for the demonstration purposes, I'm showing you how you can rebuild that. So human resources.employee. Okay. So we have reorganized one index, and we can check the status again for this particular index. Earlier one copy was coming. Let's see how many instances are coming after reorganizing. So only one copy is coming, which is now have a fragmentation level of 0. Earlier the fragmentation level was also the same, but yeah, I was just showing you the syntax how you can reorganize a particular index. Now let's share another example. I will alter one of the indexes on one of the tables. Let's see if we have this index, and this index is a column store index. So let's see if it is present. It should be in the, let me try to look for the table. So the table is not present over here. So it's all together in another database. I don't know if we have that database. That's the My AdventureWorks warehouse database. So we have that. So for this example, we will use another database altogether, which is AdventureWorks 2022. And we will rebuild one of the column store indexes present over here. The table in question here is the dbo.fact reseller sales. This is the table, and this has an index, and this is a column store index. So that column store index is not present over here. This is a normal index. Let's see the properties whether it's row store or column store. So looks like it's a row store index. I'm not sure about this. So let's not try to rebuild this. Later on guys, we will show you how you can reorganize any column store indexes once we cover the topic of column store indexes. So you should keep subscribed to my channel. I will soon be starting videos on the column store indexes, so you should watch out all the practicals. Let's close out this query and let's not use this database. Let's stick to the my adventure works database where we were rebuilding some indexes. Now let's try to rebuild all the indexes using the transact SQL statement for the human resource.employee table. So if we want to rebuild all the indexes, so for that we will use the alter index all statement, and we use the human resource employee table. We do not specify the index name here because we are specifying the all option to rebuild all the indexes. And then in the end, we will put the keyword reorganize to reorganize all the indexes on this particular table. So this is the statement. You should take note of that, and let's execute this statement. Now all the indexes for human resources dot employee table are reorganized. Now we will show you statements to rebuild 10 index. Let's remove this condition and execute this statement again. So right now we see person.person table is 100% fragmented and its cluster index is fragmented, 100% fragmented. So what we will do, we had tried the reorganize operation with this index, but the fragmentation is still the same. Now let's try to rebuild this index altogether. So let's work on this index. So for that we use the alter index name. We can take that. Let's take this index and see what's the condition of this index. So we are getting 5 rows over here. One is showing 100% fragmented. Let's take this and try to put this index name, and this is on the person.person table. So let's specify the table name person.person, and now we are rebuilding the index instead of reorganizing it, so we should specify the rebuild option. Let's try to rebuild this index. Click on the execute button and the index is rebuilt. Let's try to execute this statement to see the status. Even right now after rebuilding it is showing the fragmentation is like 100%, but the page count is less, so we are okay, and there are multiple copies of it showing up over here. So the one with the largest page count is okay for now, so we should be okay. The one which is showing the fragmentation of 100% is only having 8 pages, so which is okay. The indexes which have a larger page count should have less fragmentation. That is what the requirement is, so we are okay over here. Now we will show you how you can rebuild all the indexes in the table using the transact SQL statement. So for that you need to use the alter index all statement, and you need to specify the table name on, let's use the product table, and we will rebuild all the indexes of this table. Now we need to rebuild with certain parameters, so we can specify certain parameters during the rebuild process. We can specify the fill factor, which specifies the density of each page of the index we want to keep. So let's keep it at 80% density, and we can specify the sort in tempdb option as well if we want to perform the sorting operation for this index in the tempdb instead of the target storage or target location. We can sort the index in tempdb as well. Earlier we talked about the sort in tempdb option in our previous videos. So sort in tempdb is specified, we have set it to on, and we don't want to recompute any statistics during the index rebuilding process. So we can specify the no recompute option, and we can recompute, and we can set it to on. This is the statement, close the bracket and put a colon. Sort in tempdb is looking okay to me. I'm not sure why it is showing me error over here, but the statement is correct. Let's execute this statement. So it is saying sort in temp. So okay, the option is sort in temp DB. I have not specified the full option. Alright, let's execute. So we have rebuilt all the indexes for the production.product table with a fill factor of 80, where we have specified the density level of the pages of the index or index pages. We have performed this sorting operation for the index rebuild in the tempdb, and we have not recomputed any statistics during the index rebuild operation. So guys, we are done with demo 2. I hope you like the content of this video. We are basically done with demo 2 and demo 1, and I hope you like the content of this video. Today we have discussed on the index maintenance methods, which are reorganize and rebuild. First we talk about reorganizing an index operation, and we have discussed it for both the row store indexes and the column store indexes. And we have then talked about how you can rebuild an index, and we have talked in terms of rebuilding row store indexes and the column store indexes. And apart from that, we have covered the topic how you can use the index rebuild operation to recover from any data corruption. And lastly, we have shown you two demos where we have shown you how you can use the SQL Server Management Studio to rebuild a single index and all the indexes. And we have also shown you how you can use the SQL Server Management Studio to reorganize a single index or reorganize all the indexes. And the same operation we have showed you by using the transact SQL as well. So I hope you like the content of this video, guys. If you really like the content of this video, please click on the like button below this video. And also guys, please post in your comments and suggestions to us. And also guys, if you are new to this channel or if you are an old viewer who have not yet subscribed to the channel, I would urge you to please go ahead and subscribe to my channel right away. There is a subscribe button below this video. Click on that subscribe button. It will give you a bell. It will give you a bell icon. Click on that bell icon. Select all notifications to get notifications regarding all my upcoming and future videos. The reason I'm asking you to subscribe is because I don't want you to miss on any of the videos that I'm creating on indexing topic during these days or during the upcoming next 10 to 15 days. I don't want you to miss any of those videos. So that's the reason I'm asking you to subscribe, so that you can get timely notification whenever I post the video on my channel. So I'm giving you 5 seconds. Please go ahead and right away subscribe to the channel. I'm waiting. So guys, I hope you must have subscribed to the channel by now. And guys, if you have good network of friends who also work in SQL Server domain, I would urge you to share my videos with them using the share button below each video that you watch on my channel. Use that share button to share my videos with your friends on any of the social media platforms. Also guys, ask your friends to subscribe to my channel in case you feel my channel or my videos can make difference in their life. Then you may ask them to subscribe to my channel as well. Thank you so much for your time on this video today, and you have a wonderful day, guys. Thank you.